In question number 3, you're given three vectors, vector u, v, and w, with these components over here. And in part A, what they're asking you to do is to add vector u plus vector v. And that's as straightforward as adding the x components of u with the x component of v, and the y component of u with the y component of v. So that would be minus 1 plus 2, that's 1. And 4 plus minus 3 is 1. In part B, we're still doing some adding, but we're doing what's called a linear combination. So you're going to add 2 u's with 3 v's. So 2 u's looks like this. It's 2 times minus 1 is minus 2. And 2 times 4, 8. Plus 3 times 2 is 6. And 3 times minus 3 is minus 9. Now, adding these components together, we have minus 2 plus 6 is 4. And 8 minus 9 is minus 1. In part C, you're asked to do the dot product between v and w. So that's like multiplying the x components together with v and w plus the y components. So we have 2 times minus 3 plus minus 3 negative 3 times 1. And so that's minus 6 minus 3, and that gives you negative 9. In part D, you're doing the dot product of u and v first, and then that gives you a number, and then you take that number and you multiply it to the components of w. So what does this look like? U dot v is minus 1, oops, minus 1 times 2 plus 4 times minus 3, and that's equal to minus 2 minus 12 is minus 14. And then we're going to take this minus 14 and we're going to multiply it to the components of w, so minus 3 and 1. And so what that gives us is 42 and minus 14. Let's clean that up a little bit. So 42 and minus 14. And then in part E, you're asked to find the magnitude of u plus v. So these magnitude signs are kind of like brackets. So you first have to do what's inside before you can actually do the magnitude. So let's add u plus v together, but we've already done that in part A. So that's just like saying find the magnitude of vector 1, comma 1. And we do that simply by adding the squares of the components together, so 1 squared plus 1 squared, and then square rooting it. And so that gives us the square root of 2, which is 1.41 dot 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 dot. And finally, in question F, you're asked to find the angle theta between vectors u and v. So I've written it out like this, theta between u and v. And the best way to do this is always to start with a scalar product. So you know the components of u and v, so you can take the algebraic scalar product between the two of them, and that's just x components of u times x components of v plus y components of x times the y components of v. And we did that over here in part D, and that's negative 14. So we have negative 14 equal to the magnitude of u times the magnitude of v times the cosine of the angle between them. And see, that's why we're doing the scalar product, is because it allows us, it gives us access to this theta here. The cosine of theta here is the angle between the two vectors. Now what we need is the magnitude of u and the magnitude of v. So quickly, let's do the magnitude of u over here, and that's just negative 1 squared plus 4 squared square root. And that gives us 1 plus 16, which is the square root of 17. And the magnitude of v, I'll do it really quickly. It's just 2 squared 4 uh, plus negative 3 squared 9, 4 plus 9, and so that's the square root of 13. Now, that means that when I divide both sides of this equation here by the magnitude of u and times the magnitude of v, I'm left with negative 14 over square root of 17 times the square root of 13 equals the cosine of theta. And now taking cosine inverse on both sides, negative 14 over the square root of 17 times the square root of 13. That's going to give me theta. And on my calculator, I see that's 160 decimal 3 degrees.